My dear students, in the second video of probability series, I will talk about some probability theorems. The very simple theorems uh, in this section. We are going to discuss about theorem of total probability. Total theorem of total probability. Let us state it. Probability of union of two events A and B, that is probability of A union B, is equal to probability of the first event A plus probability of the second event B minus the probability of their intersections, that is probability of A intersection B. In Venn diagram, let us see what is this. In general, A or B, any two events. For that, this rule is called theorem of total probability. Now in Venn diagram, we can represent the events A and B by two intersecting circles. These two circles, circle 1 represents the event A and circle 2 represents the event B, and their intersection part, this is obviously A intersection B. It is easy to remember that probability of A plus probability of B, in these two probability quantities, this part comes twice. This part is coming twice, one in A and one in B. So to find the probability of their unions, that is total, we have to add the probabilities of A plus probability of B and subtract once this part, because it has been taken twice. Very easy to understand. Okay. One example. Take a die. Take a single die. The outcomes we know are 1 up to 6. It's very easy. One throw of a die. Let A be the event that 1, 2, 3, 4, and B be the event representing 2, 3, 5, say 2, 3, 5. Now A intersection B, obviously they are common elements, that is here the common outcomes is obviously 2 and 3. 2 and 3 is common. So this is the event A intersection B, which represents the intersection part. Okay. Now to find probability of A union B by the theorem of total probability, we will calculate by the formula underlined above, that is, you can see PA plus PB minus PA intersection B. So that will be PA union B. Here PA, there are 4 elements or 4 outcomes out of 6 outcomes. So that will be 4 by 6. It is easy to understand. 4 are favorable out of total 6 mutually exclusive, exhaustive and equally likely events. And probability of B, you can easily see that will be 3 by 5. There are 3 outcomes in favor of the event B. So that will be 3 by 6. and probability A intersection B will be 2 by 6. So you can easily calculate the required probability. Okay, so that will be obviously 6. 4 plus 3 is equal to 7 minus 2, so that will be 5. So 5 by 6 will be the probability of occurring the event A union B. So to make it clear what union means in general, when a problem is given to you, you will find the terms or either or like that, at least one, at least one. Okay, at least one. If these two terms come in your question paper, then you will use the formula this. A particular case of this formula is obviously when the two events are mutually exclusive, like that they have no common parts. Like that you can see I am drawing here A and B has no common part, like that. Okay, then obviously their intersection part is phi, that is A intersection B. A intersection B part will be phi. So the probability of A intersection B will be A intersection B will be obviously P phi, a null set. Null set, phi is a null set, so the probability will be 0. So the formula here will be reduced to PA union B is equal to PA plus PB. This part will vanish due to the mutual exclusiveness of A and B. This part probability will be 0. So for mutually exclusive events A and B, for mutually exclusive events A and B, we find that probability of A union B is equal to obviously PA plus PB. PA plus PB. You can do some more sums from your book, to clearly understand these two cases. So in this video we have tried to understand the theorem of total probability. This theorem can be extended to n number of events, not only for 2 events. Okay, I will be coming in the next video.